So the lymphatic system, which is what we're going to be talking about today, and it's really a part of the circulatory system, sort of, the immune system, kind of crosses between both of those. Okay? It has immune function, also related to circulation. So the lymphatic system is basically a system of vessels that run all throughout our body. So just like we have blood vessels that carry blood, we also have spread throughout our body these lymph vessels. Okay? And they carry body fluid, this lymph. And lymph, really, it starts off as a part of our blood. What do we call the liquid part of our blood? Plasma. When the blood gets to the capillaries, because of the pressure, that plasma gets forced out of the capillaries, and it surrounds the cells. Once it's out of the capillaries, we sort of call it lymph. And so that lymph, it needs to get back into the blood at some point. And so these lymph vessels are what carry that fluid back and eventually put it back into the blood. But along the way, it does some other things. It doesn't just put it back into circulation. It's also responsible for filtering out certain things, and we'll talk about that. Okay? So the lymphatic system works together with the immune system. And it's a system of tubes that carries this lymph fluid around our body. And so as the lymph is circulating around, it's picking up foreign cells and waste materials. It has special cells in it called lymphocytes. Another name for a type of white blood cell. And so as this fluid is circulating through our body, any bacteria or viruses that might be there, helps to destroy them, helps to filter them out, okay, so that they don't stay within our body. Eventually that fluid gets back into the blood and it's completed its cycle. But as it's going through these vessels, also it goes through these areas that Grace mentioned before. They're enlargements in these lymphatic vessels that are called lymph nodes. And these lymph nodes are an important part of our immune system. That's where bacteria and viruses actually get trapped and destroyed. As the lymph fluid picks up these pathogens, when it brings them to these lymph nodes, they can be destroyed there, filtered out. Because they're full of these white blood cells that help protect them. So basically anywhere in our body, just like we have blood vessels all throughout our body, we also have these lymph vessels throughout our body to take this fluid and redistribute it around. Now, these lymph nodes, they're sort of scattered throughout our body, but they are more concentrated in certain areas. Around in your neck, okay, in this area, you have lots of lymph nodes. Under your arms, in the groin area, in the chest. In fact, I don't know, maybe my grandmother used to say, like, if you're sick, she'd feel my neck. She'd, oh, your glands are swollen. You ever heard that? What really swells up when you get sick, like you have the cold or the flu, what you can feel are these lymph nodes that are in your neck. Because they enlarge, they fill up with white blood cells to help battle the infection that you have. And so they swell up. Sometimes they might be sore. You could feel them. They sometimes bulge out. Those are lymph nodes that you can actually feel. Alex? Yep. Yep. No, it's sort of through the tissue, not in the bone itself, but nearby. So here's kind of a diagram of how this looks. So we have arteries bringing the blood to various parts of the body, and it gets to a capillary. That's where fluid from the blood gets forced out. but then it can return back to the blood by going through these other vessels, which are the lymphatic vessels. They eventually, like we said, bring this lymph fluid to a lymph node to be filtered and then put it back into the blood so that the blood has enough plasma in it. And you see a couple other, same thing. This is a lymph node that you see filled with white blood cells. As the lymph goes there, the white blood cells can destroy any pathogens that might be there. And these are called lymphoid. So does anyone have your tonsils out? They don't do it as much anymore. My daughter, she got strep throat like 6 or 7 times when she was younger, and she eventually had her tonsils removed. But tonsils are in the back of your throat. They will enlarge also. When my daughter was sick, they were so big they almost clogged up her throat. Because they enlarge when you're sick because they're part of the lymphatic system. You can have them removed, okay, and you can function just fine without them. Also your spleen, bone marrow, the thymus gland, these are areas that help as part of our lymphatic system. They create these white blood cells and they help build up our immune system, especially as we're younger. All right, now there are a very common disease, not so much here, but in tropical countries, there is a parasitic worm. It's transmitted by mosquitoes.
Oh, I know.
And this worm, you don't have this slide, I'm just going to tell you about it. This worm, like all parasites, is a very specific sort of life cycle. And this worm, when it's introduced into a human, it goes into their lymphatic system. And these worms live in these lymph vessels, in the lymph nodes, and they reproduce and grow and get larger. What happens is they end up clogging up the lymphatic system. So this body fluid that's supposed to be circulated around can't move through the lymphatic system very well, and it starts to build up. It starts to pool in the tissue, especially in the lower extremities. The feet, the calves, the thighs starts to swell up because this fluid can't get back into circulation. And they swell up, the skin begins to thicken, often a person gets infections, becomes irritated, and it can swell up to 5 or 6 times the normal size from this worm that's living there. So there's some pictures in here of people that have been affected by this. And it affects 120 million people throughout the world, so it is quite common. There are certain ways that they're trying to control it by controlling this mosquitoes. It's caused by a very specific type of worm and mosquito. But here are some examples. Here you see this person, obviously their right leg is extremely swollen with that lymph fluid. It's just surrounding the tissue. It can't get back to recirculate because these worms are clogging up the lymphatic system. And you know, it can get worse. Sometimes it's only one leg and not the other. Sometimes it's worse in one than the other. And there's not really great treatments for it as well. So there's another example, a person with a swollen leg. Okay. There's an extreme case. Okay. Again, when you get to these cases, a person can't move around very well. And again, this is just this inflamed, swollen tissue. There's the most extreme example of that. It's a person's thigh, and their leg, and their foot. And again, you see in their other foot is not affected by these worms. The worms haven't really made it in there, but this one is obviously just extremely swollen and irritated. All right, so let's move on to a more familiar system, the digestive system. So I'm sure you guys studied this. What's the purpose of our digestive system? You say in your own words. Jenna?
To break down food for us to use as energy.
Exactly, to break down food. So you, let's say you ate a Pop-Tart this morning for breakfast. Well, little chunks of Pop-Tart don't go into your blood and circulate to your brain cells. What has to happen to that Pop-Tart? What's that? It has to dissolve, has to be broken into tiny little, what it gets broken down to are just simple sugars and amino acids and fatty acids. Very simple microscopic molecules. The big foods that we eat have to be digested before we can actually use them, before they can even get into our bloodstream. And that's the purpose of the digestive system, to break down large molecules into smaller molecules and allow us to absorb them into our blood. It starts in the mouth. That's where digestion begins. What do you do to start digestion in your mouth? We often might not think of the mouth as a digestive organ. Kara? Yeah, chewing up your food. When you chew your food, that's a process called mechanical digestion. If you eat this delicious looking veggie burger, you start chewing it up. What you're doing is you're breaking it into smaller and smaller pieces. It's much easier to digest something that's in lots of little pieces versus one big chunk. When you chew food into smaller pieces, you increase the surface area, and then your digestive enzymes can work on it better. So that starts in your mouth when you chew your food. But also in your mouth, a different type of digestion takes place, chemical digestion. Chemical digestion is when certain enzymes are used to actually start to chemically break down the food. And how does that happen in your mouth? Grace? Your saliva. So saliva, it's not just like water. It's a mixture of fluid and a digestive enzyme called salivary amylase. And that starts digestion. Do you know what saliva starts digesting? One specific type of food molecule. No, a specific one. Close. It digests this into sugar. Starch. It takes starch that you might find in bread or a cracker, something like that, pasta, and it starts breaking starch into simple sugars that your body produces. It has enzymes in it. Saliva is produced in special glands. They're like in your, below your chin and in your back of your, behind your jaw, salivary glands. And every once in a while, they squirt some saliva into your mouth. Hopefully, it's not while you're yawning, even though this probably happened to you. You're looking at your phone or reading a book and you yawn, and then you get a little spray on your book or on your phone. Has that ever happened to anyone? Yeah. It's because your salivary gland happened to be spraying some saliva when your mouth was open, and it sprayed right out of your mouth. So they do that every once in a while. What happens if you're hungry and start thinking about food? You smell it. You ever hear if your mouth starts watering? And what's happening is your brain is telling your salivary glands, hey, there's some food, I can smell it. Or you're thinking about it and it starts getting your mouth ready to start digest that food, and that's why you have that feeling in your mouth.
So without that food in your mouth, does it kind of make you full?
Not so much makes you full, it just helps to start off the digestion. And then you swallow it, so you start chewing your food. Saliva starts to break down the starches, and then eventually you swallow it. The food travels down a pipe. It's just a pipe called the esophagus. Okay? It's about this long. Leads from your back of your mouth into your stomach. When you swallow your food, the food doesn't just like plop down in your stomach because of gravity, right? It doesn't just like... Your esophagus actually squeezes. One muscle has these rings of muscle, and one muscle squeezes, then the one below, and the one below, and it kind of like squeezing out toothpaste, it squeezes this food down into your stomach. That process of squeezing the food into your stomach, it's called peristalsis. And it's also how the food moves through your intestine. You can even drink a glass of water upside down because of this squeezing process. And at the end of the esophagus is a little opening, a little muscle that opens and closes to allow the food into your stomach. Hello? Sure. Thanks. Kira, can you stop in the office? So, the esophagus squeezes that food into the stomach. And what happens what's the stomach like?
A bunch of stomach acid.
Yeah, it has acids in it, hydrochloric acid. It's kind of like a pouch, a muscular pouch filled with this hydrochloric acid. It's got a special lining so that it doesn't get damaged by these strong acids, because this hydrochloric acid helps to break down the foods that we eat. So the foods that you eat starts off as, solid chunks of food at the end of the press card, just at the very end. And then this acid starts breaking it down into a more liquidy substance called chyme. Alex? Yeah, in fact, good question, because that does happen to people. Some people, the lining of their stomach gets damaged or wears away, and the stomach acid actually starts to damage their stomach, causes pain, can cause internal bleeding. Does anyone know what we call that? You probably have heard it before. Yeah, some people say stress can cause this to increase. An ulcer. It's called an ulcer when the stomach acid starts to hurt the stomach lining itself. Also, sometimes this acid, this muscle that closes off the stomach, sometimes doesn't close all the way, and stomach acid can go into your esophagus. Probably not so much with you. I used to happen to me all the time. Happens as you get older. Do you know what we call it? Acid reflux or heartburn. Heartburn has nothing to do with your heart. It's a burning sensation you feel in your chest, but it's because the stomach acid is going up your esophagus and causes it to burn. If you have it for a long time, it can damage your esophagus. So there's medicines you can take to help prevent that from happening. So in your stomach, these acids are breaking down the food. It's going, and you know this if you've ever, I'm sure we've all vomited before, that if you get sick soon after you ate, you still have recognizable pieces of whatever you ate. If it's been 5 or 6 or 7 hours, it's just like a liquid, like soup, and you can't recognize it because the foods that you ate have been broken down. When you do get sick, basically peristalsis, that squeezes the food into your stomach, happens in reverse, and it squeezes the contents of your stomach up and out your mouth. Is vomiting beneficial? How is it a protective reflex for us, Luke?
Your body knows that something that you ate is causing you to get sick, so it's getting it out.
Yeah, it's basically your body responds to some sort of illness by saying, maybe we ingested something dangerous, something that's causing an infection or food poisoning, and your body gets rid of that so you don't get any more into it. It's also why certain smells or certain things we find like revolting and like make you gag or get sick, because the things that we find gross, disgusting, like a dead animal or dog poop or something like that, because those things could carry bacteria that are harmful to us. So it's our body's sort of adaptation of staying away from those things to help protect us from those possible dangerous things beyond those things that we find gross. After the food passes through the stomach, it's basically this acidic liquid, and it then can start to move into the small intestine. The small intestine is called small because it's relatively narrow, but it's actually quite long. My small intestine could probably stretch all the way across this room to the back of the window, but it's all coiled up inside your abdomen. Food needs to take this long 25-foot journey through the small intestine. Along the way, enzymes are working, different types of enzymes to break down the food. And also, the nutrients from the food are being absorbed into our blood. Sugars and proteins and amino acids are being absorbed into our blood to be distributed throughout our body. Most digestion actually takes place in the small intestine, more than even in the stomach. So the food makes its way through this long tube, being digested even further. Nutrients are being absorbed all along the way. And there's some other organs that are related to the digestive system, but the food doesn't go through these. Food does not go through the liver, gallbladder, pancreas. They just sort of help out. The liver does a couple things. In terms of digestion, it makes a substance called bile. It also helps filter toxins out of our blood. Bile is a substance that helps to break down fats. So if you eat a meal that has fats in it, you ate a bunch of French fries, the oil in those French fries is fat. To break down that fat, bile is the enzyme that helps that happen. Our liver makes bile, and then it sends it into another organ called the gallbladder to kind of store it away until it's needed. And once you eat a food that's high in fat, your gallbladder will squirt a little bit of this bile into your small intestine to help you to digest it. Sometimes people have problems with their gallbladder. Sometimes they can form little secretions, gallstones that are painful. Sometimes it gets inflamed, causes them to have like pain. My wife would get this all the time. She eventually had her gallbladder removed. You can live fine without your gallbladder. What happens is there's no storage area anymore, so your liver just sends the bile directly into your small intestine. And you can live just fine without it. And so the gallbladder stores up the bile and squeezes some of it into the small intestine every once in a while when it's needed through this tube called the bile duct. The pancreas is similar. It produces some digestive enzymes. They're called pancreatic juices. And it's a mixture of enzymes to help digest various things that we eat. They also release these enzymes into the small intestine. In this tube, the small intestine, the inside is not smooth like a hose. The inside is actually filled with all of these sort of folds and projections. They're called villi. Oh, pancreas also creates insulin. We mentioned that in the endocrine system. The small intestine has, if you look here, the inside looks like a whole bunch of fingers sticking up from it. The purpose of these villi are to provide a very large surface area where we can absorb nutrients. Because inside of these villi are where the blood vessels are. So the food, as it's passing over these, the nutrients can go through the villi into the blood. So once the digested food has made its way all the way through all the small intestine, it's fully digested. Basically, all of the nutrients have been absorbed from the food. Anything that our body can use, vitamins, most of the vitamins, all of the nutrients are absorbed there. And then the last stop is the large intestine. So once the food winds around this whole small intestine, it goes in to the large intestine here. Large intestine is also called the colon. And it rises up the right side of our body in our abdomen, goes across our abdomen, goes down the left side of our body, and then out of our body through the rectum. Opening is called the anus. The food that's traveling here in the large intestine, basically almost everything of value has already been absorbed into our blood. And what's left is things that our body was unable to digest. Fiber, and water, and some vitamins. And so as the food's finishing its journey through the large intestine, our large intestine reabsorbs water from it so that we can recycle that water. And then anything left is removed from the body through the rectum, through the anus as feces. And that's just undigested material that our body doesn't have a way of digesting. No actual digestion happens in the large intestine. It's already fully digested by the time it gets here to the large intestine. So, anyone heard of the colon before in another context? Yeah, that sometimes you may know your parents or somebody might have to have a colonoscopy. It's when they use a camera to look inside of a person's large intestine. Because colon cancer is a fairly common type of cancer. So they can look for any signs of colon cancer by doing a colonoscopy, by using a camera to look in the large intestine, make sure everything's okay. Sometimes the large intestine leaves excess water in this undigested food. Do you know what that causes? Excess water in the undigested material leads to diarrhea. Too little water left in the undigested food can lead to, it's the opposite, constipation. Brandon? It's what? I don't think it does. I'm pretty sure. I don't know that I've ever been hit in the liver. It's protected kind of by your rib cage.